Hello students, myself Dr. Vijayalakshmi. In the last video, we studied about some condensation reactions like aldol condensation, Cannizzarose reaction, mixed aldol condensation, etc. So in this video, we study some other reactions. For example, Perkins reaction. In the Perkins reaction, aromatic aldehydes, for example benzaldehyde, when treated with anhydride of an aliphatic acid. So here aliphatic acids are formic acid, acetic acid, ethanoic acid, propanoic acid. Okay. So anhydride of an aliphatic acid, for example acetic acid. Its anhydride is acetic anhydride in presence of sodium salt of that acid at 180 degrees centigrade to give alpha beta unsaturated acids. So here example taken is a benzaldehyde. When it is treated with aliphatic acid, that is acetic acid, its anhydride, so acetic anhydride in presence of sodium acetate, the salt of the acid. So in presence of sodium acetate at about 180 degrees centigrade, these two will react and gives alpha beta unsaturated acid. The functional group adjacent to the functional group, this is a alpha carbon and this is beta carbon. In between alpha and beta carbon there is a double bond, so it is called alpha beta unsaturated acid. So this is called Perkins reaction. In the Perkins reaction, aromatic aldehyde when treated with aliphatic anhydride of an aliphatic acid in presence of salt of that same acid at 180 degrees centigrade gives alpha beta unsaturated acid. Let us see the mechanism. So first step is formation of anion from acetic anhydride. So acetic anhydride reacts with the sodium acetate, the acetate ion which is obtained by the sodium acetate. Sodium acetate will take a proton from this acetic anhydride. So after giving this H plus, this acetic anhydride means CH bond electrons are given to the carbon so that it becomes anion CH2 minus. So when it becomes anion, it is stabilized. So that's why it gives H plus easily. How it is stabilized means here CH2, it having a negative charge, adjacent to that C double bond O, another one oxygen, then C double bond O is there. These electrons are given to CC bond and CO bond electrons are given to oxygen. So thus this negative charge can be delocalized. So thus anion is stabilized, so it gives H plus easily and it forms anion A. In the first step, anion A is formed from acetic anhydride. Next, this anion A acts as a nucleophile. It attacks the benzaldehyde. It attacks the carbonyl carbon of benzaldehyde. So in presence of attacking reagent, the electrons of C double bond O are shifted towards oxygen. So that oxygen becomes minus, C is plus. To that this nucleophile, that is anion A, will be reacting. So it forms a new C bond. So it forms another one anion, that is anion B. Now the charge is on the oxygen, O minus. So this is anion B. Nucleophile added to benzaldehyde and gives anion B. This anion B now accepts a proton from this acetic acid which is formed in the step 1. So it accepts proton from acetic acid. These two act as an Lewis acid and base. So it accepts H plus and becomes OH, and again the acetate ion is generated back. this compound that can be called as a C, after accepting a proton, this O minus becomes OH, and the reaction mixture on heating, what happens? This CH2, which is called alpha carbon because adjacent it having some functional group, carbonyl group is there. This is alpha carbon and beta carbon. One of the CH bond electrons of these are given to carbon-carbon bond and H plus is removed, and COH bond electrons are given to oxygen. So OH minus is removed and carbon-carbon new double bond is formed, and H plus and OH minus as H2O is removed. So here compound D is obtained, which is having unsaturation at alpha and beta carbon. But still this is unstable, so it undergo hydrolysis. So on hydrolysis, carbon oxygen bond, so it is like this, C double bond O, O, CO, CH3, and this carbon oxygen bond undergo hydrolysis on both sides. So one side OH and another side H is added, so it becomes C6H5, C6H5, CH, CH, COOH, C6H5, CH, CH, COOH. So the unsaturation is at the alpha and beta, in between alpha and beta carbon. So the obtained product is called cinnamic acid, and another one is acetic acid is generated here. So this is called Perkins reaction. In the Perkins reaction, aromatic aldehyde treated with anhydride of an aliphatic acid in presence of sodium salt of that same acid at 180 degrees centigrade. So it gives alpha beta unsaturated acids. Another one important name reaction in this chapter is Baeyer-Villiger oxidation. This Baeyer-Villiger oxidation of acyclic or cyclic ketones to esters takes place. Acyclic or cyclic ketones are converted into esters or also called as lactones. So in presence of per acids such as perbenzoic acid, peracetic acid, trifluoro-peracetic acid. So perbenzoic acid, for example, structure of perbenzoic acid is, actually benzoic acid structure is C6H5COH. This is benzoic acid structure. Perbenzoic acid structure is C6H5 C double bond O OOH. So another one extra oxygen OO, like the peroxide oxygen bond is present, therefore they are called per acids. For example, peracetic acid. Acetic acid structure is CH3 C double bond O OH. This is the structure of acid, but per acid is CH3 C double bond O OOH. So this OO bond, like the peroxide, here bond is present. So these are called per acids. So when in presence of per acids, these oxidation of acyclic or cyclic ketones takes place and they gives esters. They are also called lactones. So for example, a ketone in presence of perbenzoic acid, it gives ester. Or cyclopentanone, cyclic ester ketone, cyclopentanone in presence of trifluoro-peracetic acid, it gives lactone. Here also C double bond OOR that is carbon bond is present, the same group here also, but it is in form of cyclic compound. So these are called lactones. And how this reaction takes place? Suppose acetone is taken, in presence of perbenzoic acid, methyl acetate ester is formed. With acetone, the ester obtained is methyl acetate. We will see the mechanism of this reaction. For that mechanism, we will take example. In presence of perbenzoic acid, reaction example will be taken. So, first step is ionization of perbenzoic acid takes place. So, perbenzoic acid, it acts as an peroxide. So, oxidation of peroxide undergo ionization and it forms this OH bond. From that OH bond, the electrons are given to oxygen and H plus is removed. So, proton is removed and anion A is formed. This anion proton and anion A are formed. This proton H plus, which is generated in the first step, attacks the carbonyl oxygen to give protonated ketone. It attacks the carbonyl oxygen of a ketone and gives protonated ketone. So see here, this is a ketone. In that C double bond O, oxygen having a lone pair of electrons. With the lone pair of electrons, this oxygen attacks the H plus. So protonation of this ketone takes place, means proton is added to the ketone. So it becomes OH. From the formation of OH bond, oxygen loses pair of electrons. So it gets positive charge. In that, this cation form is resonance stabilized. That is, among that C double bond O, the pi electrons are given to oxygen. These pi electrons are given to oxygen so that carbon gets a positive charge. So the positive charge which is formed on the oxygen can be delocalized to carbon also. So again, the pair of electrons are given to carbon-oxygen bond. So it forms a double bond and oxygen gets a positive charge. So thus, when this protonated ketone is formed, this will be resonance stabilized. Now it forms a carbocation 1. Resonance stabilized carbocation 1. In the third step, the anion 1, which is formed in first step, attacks the carbocation and the compound form is further migration of R dash group, that is any alkyl or aryl group, to oxygen takes place, resulting carbocation 2, which is further resonance stabilized. So this is anion 1, which is formed in this step 1. This is carbocation formed in this step 2. Now the anion 1 acts as a nucleophile. It attacks the carbocation, so that carbon oxygen new bond is formed here. Carbon and oxygen new bond is formed. But as here oxygen bond is present, easily the migration of this alkyl group takes place. So here R dash group that reacts with the oxygen. So here this oxygen, here oxygen also having a lone pair of electrons. So this R dash reacts with that lone pair of electrons. So new oxygen R dash bond is formed and oxygen bond electrons are given transferred to oxygen. So C6H5 COO minus. This is benzoate ion is removed and this R dash group is shifted to oxygen. So migration of R dash to oxygen takes place and it gives carbocation 2. As the alkyl group is shifted to oxygen, this carbon gets a positive charge. So carbocation 2 is formed. and this carbocation too, that delocalization of this positive charge between oxygen and carbon, that can be resonance stabilized. Now in the third step, again the resonance stabilized carbocation is obtained. In the last step, loss of a proton takes place and to give ester. Among this OH bond, the electrons from this hydrogen are given to oxygen and H plus is removed. So here H plus is removed and OH bond electrons are given to oxygen, so that this oxygen gets back its lone pair of electrons again, and OR bond. So this is called ester bond, COO, ester bond, and H plus is proton is removed, which is added in the first step. So now the ketone is converted into ester. So this is called Baeyer-Villiger oxidation. Two syntheses are there. Synthesis of coumarin. Salicylaldehyde, when treated with acetic anhydride in presence of sodium acetate, orthohydroxycinnamic acid is formed, which decomposed on heating to form coumarin. So coumarin is one of the important compound used in many drugs. So the synthesis of coumarin is by taking salicylaldehyde. So when salicylaldehyde treated with acetic anhydride in presence of sodium acetate. So already we seen this reaction, Parkinson's reaction, aromatic aldehydes treated with anhydride of aliphatic acid in presence of salt of the same acid. So here aromatic aldehyde is salicylaldehyde. In presence of acetic anhydride, the aromatic aldehyde example is salicylaldehyde. It reacts with acetic anhydride in presence of salt of acetic acid, that is sodium acetate, and it gives orthohydroxycinnamic acid, that is alpha beta unsaturated acids are obtained. So this reaction is called Parkinson's reaction, that we already studied. So here the Perkins reaction is applied. So once the ortho-dihydroxycinnamic acid, that is alpha beta unsaturated acid, is formed, on heating, here mole of water is removed from these two OH groups. A mole of water is removed as H2O and only one oxygen remains here. So carbon, oxygen, carbon. This carbon, oxygen and carbon new bond is formed. In between these two OH groups, from one of the OH group H and another OH group as H2O is removed, carbon, oxygen and carbon new bond is formed, and this is called coumarin. This is very important compound which is synthesized from this salicylaldehyde through Parkinson's reaction and is used as an important drug. Synthesis of vanillin. So you also may heard the name of vanillin. Synthesis of vanillin. Orthomethoxyphenol. So here orthomethoxyphenol, when treated with chloroform in aqueous NaOH followed by acid hydrolysis, vanillin is formed. Orthomethoxyphenol. This is only benzene ring with OH group is phenol. OCH3 group is methoxy group, which is at the ortho position to the OH group. So it is orthomethoxyphenol. When it is treated with chloroform CHCl3, aqueous NaOH, that is NaOH which is dissolved in water, so aqueous NaOH, or alcoholic NaOH means NaOH is dissolved in alcohol. So in presence of aqueous NaOH, this chloroform is added at the para position. So initially it is added at the para position, so it forms the carbon. Here chloroform is added at the para position C, 3Cl, so like this it is added. Benzene ring, OH, methoxy group, CH3, and at the para position one hydrogen and one Cl is replaced. This carbon and 2 Cl are added here, CHCl, like this. But when treated with NaOH, this Cl is replaced with hydroxyl group, so they becomes OH. But on the same carbon, 2 OH groups, it is unstable, so a mole of water is removed, then CHO is remained. So here CHO is remained. So this reaction is called Reimer-Tiemann reaction. So after this formation, in presence of NaOH, base is there, therefore phenol, which is a weak acid, it also converted into a salt. Now on acid hydrolysis, again the salt is converted into phenol, and this is called vanillin. So vanillin and coumarin are two important compounds which are used in the drugs, synthesis of some drugs. Thank you students. Here aldehydes and ketones chapter is completed. If you have any doubts, you can message me through WhatsApp or through mail. You can ask your queries. In the next video, we'll give some assignment questions, that is important questions from this topic. Thank you students.